Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 18 in the cross-site scripting module titled Reflected XSS into HTML context with all tags blocked except custom ones. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all labs, do a search on cross-site scripting labs, and then go to lab number 18, titled Reflected XSS into HTML context with all tags blocked except custom ones. All right, let's get started. This lab blocks all HTML tags except custom ones. To solve the lab, perform a cross-site scripting attack that injects a custom tag and automatically alerts on the document.cookie. All right, so the target goal over here is to perform an XSS attack that alerts on document.cookie. So it displays the cookie of the user. All right, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being intercepted in my Burp proxy. I am using the professional version of Burp, however, all the features I'll be using are also in the community edition, and so you don't really need the professional version. It's just that for the intruder portion of the attack, I don't want to sit and wait when using the community edition, and so I just use the professional version, which is much faster. All right, so the first thing you do when you're testing for cross-site scripting vulnerabilities is you look for client-supplied input that is reflected back in the application. So in the search functionality over here, I'm going to add the keyword test, click on search, and as you can see over here, my client-supplied input is being reflected back in the application, and so this field definitely needs to be tested for cross-site scripting vulnerabilities. What I'll do first is test it for a really obvious and classic case. So I'll say script, alert 1, and then end the script tag, and click on search over here and see if the application accepts it. So I get a custom error, likely from a web application firewall, that says this tag is not allowed. So now what I'm going to do is try to see if there are tags that are allowed that it could potentially allow me to perform my cross-site scripting attack. So to do that, let's search on just script itself, click on search, intercept the request in Burp, and then let's send this to intruder. So what we're going to do is we're going to get all the possible tags, and then we're going to automate the process of figuring out which tags are allowed and which ones are not. So let's clear over here. The less than and bigger than signs don't actually need to be URL encoded, so I'm just going to rewrite this over here. And the part that we want to automate is this one over here. So this is the field where we're going to enter a bunch of tags and see which ones work. If I get this message over here, that means that tag is not allowed. However, if I get a 200 OK message, that means that tag is allowed. So to get the list of tags, I'm going to Google XSS cheat sheet portswigger, hit enter, and on the first entry over here, you get a really useful resource for cross-site scripting that gives you the list of all tags and then all the events and then for which browser. And once you put your selection over here, it actually gives you the option. It tells you what it does, and then it gives you the payload that you could use. So this is a really useful resource that we're going to use when we're trying to bypass web application firewalls. The first thing I'm going to do is figure out which tag is allowed. So let's copy tags to clipboard. And then in payloads, paste it in here and run our attack. So in the community edition, again, this works. It's just going to be much slower than in the professional version. So let's go on status right over here. You see that there's a bunch of tags that are allowed, which is quite odd because the name of the lab is all tags are blocked except the custom ones. So I'm just going to go over here and see if it's all done correctly and see the response and render it. And interesting. So there might be something wrong with the lab that is preventing all these tags. However, when that gets fixed, I don't want to provide you with the wrong solution. So let's assume that all the tags were blocked except for custom tags. So in this case, we're going to try and solve the solution with a custom tag. So let's close this off, discard, and go back to our cheat sheet and select custom tags. and we want it for, let's say, the Chrome browser. And here we go. So you're presented with a bunch of options for custom tags. And now the next step is just to select a payload that could potentially work on the application. So over here, this fires when a CSS animation ends. I don't really like that. This one is when a CSS animation starts. This one fires when the element has focus. So let's try this one out. Let's copy it, put it in here. And then instead of alerting over here, I'm just going to say console.log and just print the message hello in the web console. So we'll know it worked if we get the message hello in the web console. So let's click on search over here. So far so good. Let's inspect and go to our console over here. And here we go. So we get the message hello, which means that the exploit worked. So now we need to deliver this exploit to the victim user. And the way we're going to do that is by using our exploit server, which is just our attacker controlled server. So we'll go over here, we'll add a script tag. So in a real world scenario, this application would look like a legitimate application. And so the user would be visiting the application, and what's really happening when the user visits the application is they essentially run this XSS code in their browser, and then they would send the document.cookie, so the cookie that is saved in the browser, to the attacker. So for now, we just need to alert on it. So let's say script location is equal to our payload. So if we go to proxy right over here, it was this one right over here. Let's copy it. First, we need our URL of the application. Let's put it in here. And then copy the XSS payload. This looks good. So essentially over here, we were just printing to console.log. What we want to do is actually alert on document.cookie. So before we send this to the victim user, let's send this to repeater and build our exploit. So over here, this is URL encoded. I'm going to do Control-Shift-U to decode it. And then instead of console.log, I'm going to say alert on document.cookie. And that's pretty much it. So let's URL encode this, copy it, paste it in here. And we actually don't want to URL encode this part over here. That might break it for us. So let's URL decode it again. And we only want to URL encode this part over here. So Control U again to URL encode it. And here we go. I believe we got it right this time around. All right. Let's paste it in here. And we need the link to the application itself. So we'll add HTTPS. And then the link to the application. And this looks good. Hopefully this should work. Now this is all in the location variable, so we need to put it in double quotes. And let's copy this, put it in notes.txt, and I'll provide you the link to the document in the description. And then let's deliver the exploit to the victim. And we don't get the congratulations, you solved the lab message, which means that there is something wrong with our exploit. So let's view the exploit. You could see over here, we're not seeing anything. Let's inspect and then go to the console, and here we go. So we're getting an error on HTTPS, which means that there must be some kind of error in our code. So let's go back. Let's minimize this. This all looks okay to me. Let's add a semicolon over here. And let's put this in single quotes. Oh, and I understand what happened. So I had put 2 single quotes instead of a double quote, and I assumed that I put a double quote, and that's why it wasn't working. All right, let's view the exploit. And we get alerted. We don't actually have a cookie for this application, and that's why we're alerted with nothing. But if we close this off and then go back to the exploit server, and deliver this to the victim user. But before we do that, let's update this over here and save it, and then deliver the exploit to the victim user. You should see the "Congratulations, you solved the lab" message. All right, so we successfully completed the exercise by exploiting the Reflected XSS vulnerability. In the next lab, we'll look at another case of a cross-site scripting vulnerability.